Okay. So first of all, RDBMS, we already got to know what it is. It's Relational Database Management System. In RDBMS, we learned yesterday that the particular database consists of table. Table is the basic unit for storing the data over here. Okay. And stored, a particular table must be having some columns. Columns, when we are creating columns, mean we are structuring the table. We have 5 columns. We are structuring the tables with the 5 columns. Means if I'm just going to add some rows over here or records over here, that particular records must be having, or not must actually, I can say, maybe having 5 different value, which will be identifying that record. Okay, it may not be having 5 record. Maybe some of the things I'm skipping. Suppose a particular table is having column A, column B, column C, column D, 4 columns, and I'm going to insert one particular record. Suppose column C is not a mandatory field from the customer to be put. So customer can neglect that particular thing. So column C for that particular record can be null. Okay. So that is the thing I am telling, that after structuring the table over there, a particular record can be inserted. While inserting the record, we need to fill up that particular element's data. This is the normal concept of filling up a table only. Okay. Now we can create a table, there'll be no issue. But as it's a relational database management system, we need to follow up some rules. Now follow some rules, just like the first rule is normalization. We need to make sure that a particular table, whatever I'm saving a particular table in the database, the table should be normalized in nature. So what is normalized? How I can make a normalized table in the database? Let's see. Okay, for this process, I created some of the tables in some Excel format. I'll be just sharing that thing to you so that the concept should be clear while understanding the normalization process. Okay. Okay. As of now, you can see this table. This table is not normalized in nature. Why it's not normalized? I'll be quickly telling you this thing and how to make it a normalized one. That thing will be also learning over here. So moving to the next slide, I'll be just, going through the process one by one over here, and we can quickly check the thing over here. And we can try to relate the same thing. If there is any stuck point anywhere, please tell me. Okay, why data normalization is required? I'm just telling first thing to you. Data normalization is a process of recognizing, reorganizing the data within a database so that users can utilize it for the further query and analysis. This is why normalization is required. And there are various advantages. Nothing we can see over here, just like duplication may be eliminated. Okay. If we are making a table normalized, the duplication, there will be no duplicate entry of the same data. The results in a smaller database. Suppose the particular table is not normalized in nature. You can see while storing the particular table in a database, the table is taking much more space in that particular database, which is not an efficient way to store the data, because we have lots of data in that particular table. If a particular single table is taking so much data, then it's hard to accommodate all the data in an efficient way. So if we just make a table a normalized one, the result should be a very smaller database. I think you are aware that if we are purchasing a database in a cloud, we need to pay some cost. Okay, cost in USD or just like this. Local currencies. But that is why we need to think about how we'll be using the particular tables, how we'll be storing the data in a particular table in the databases and all. Everything we need to think about. Okay, the next point, minimize or avoiding issues with data modification. If we have data in normalized process, there will be very less chances of having issues with data modification. The query means SQL query should be much more easier. While fetching the data, it should be very fast. Okay, or while pushing some data into that table, it should be also very fast if we have data normalized in a particular table. So those are the various things we can say about the normalization process, which is very much important to be maintained in a particular table. Now, how to normalize a table? Suppose the table is not normalized. The same example I'm giving over here. You can see the table is not normalized. Why it's not normalized in nature? First point, here you can see duplication is there. Actually, this table, I just collected this information maybe from a coaching center. A coaching center is having a student ID against a particular student. Okay. Student name, course ID, course fee. I just collected these 4 columns. I'm creating one table having these 4 columns: student ID, particular student's name, which courses they are learning, and how much fees they are paying. Okay. So, uh, for the second record, you can see 12 Sonu, course ID A1 to A13. The particular student is learning 2 different courses. That's why he or she is paying this 800 and 300 for each of the courses. And the same record is getting repeated over here. Maybe some issue with the particular student, they have entered this thing twice, or maybe some issue with the particular manager or anyone who is, who just provided the same thing to me. Or maybe I mistakenly put 2 different records over here. That mistake can be done from anyone, but it is a normal scenario. You can see lots of duplicates can be there in the table. This can be for multiple reasons, but this is causing big issue while doing some calculation. Suppose you are doing some aggregation. You did not check the duplication. Suppose you are checking how much Shonu is paying. Without checking the duplication, if you just make an aggregation on top of this column, you can find duplicate of this on top of this course fee, which should be causing a big issue. Okay. That's why for the normalization process, the first term we need to check the particular table should not be having any duplication. This row and this row should be unique. Okay. Apart from that, you can see the other rows are fine. There are no duplicates, only this 2 rows. So, as per the normalization process, the first step should be remove the duplication. I'm just checking once more time. What are the method over here? Let me just open my PPTs once more time. So there are 2 process I'll be mentioning over here. The 2 consecutive process. The first process will make the denormalized table to first normalized form, or it's called first normal form. I'll be just applying some of the process on denormalized table to make it a first normal form. Okay. So what are the process? The first process I just mentioned, the record should be unique. Okay. And another things I just need to check, each of the cell should contain a single value. Okay. So to make a first normal form, these 2 things I need to check. Over here, I can see this kind of row, this particular row, those rows are having, especially the course fees column. It's having multiple data assigned to it. Okay. Course IDs as well. 2 course IDs are mentioned over here, and 2 course fees are mentioned over here too. Okay. So I want to I just need to remove. First of all, I'm just removing the duplicates over here. So if I just remove the duplicates, the thing should be just like this. Okay, I'm not taking this value. Okay, this is the first way we can remove the duplicates. Second part, we need to split out the thing. Means I'm not placing A12 and A13 in a single cell over here. Rather, I can just have an entry for A13. Let's keep this thing for A12. Let me just not highlight this thing. Okay. So let me keep A12 over here and remove A13 in a new line. So a new line is getting inserted over here just to remove multiple elements from a single cell. Okay. This thing is completed. We just splitted this thing into different row items. Similarly, for this row, I'm just eliminating A13, A11 and A14. So, okay, it's fine. So we have deleted this particular row as well as we have splitted this multiple elements into new line items. You can also see now there is no such duplicates. You cannot mention this thing as duplicate because only student ID and student name is same, but course IDs are different. Okay, now I can say this table is a first normal form. This table is in first normal form. Okay, I mentioned the same thing over here. Okay, this is nothing but this table only. Okay, now we need to check how we can achieve the second normal form. And we can say this is one of the, if we just achieve second normal form, we can tell that my table is normalized in nature. There are third normal form as well, but which is not very much important, and I'll not be highlighting this part over here. As of now, let's learn second normal form. Okay. So to achieve second normal form, first of all, we need to check whether the table is achieving the criteria of first normal form. This is the first criteria. Yeah, we definitely have completed this thing over here. Let me delete this thing. Okay. This is our table, which is in first normal form. Now I need to check the primary keys. I have told you what is primary key in the last day. I hope you can remember. If there is any stuck point, please tell me. Okay, let me repeat once more time. What is primary key over here? For this table, you can see the primary key student ID. Student ID should be there, but it's a duplicate over here. If I remove this column, remove this row, if I remove this row only, let me just do one thing. Let me just copy and paste until this. I just removed the duplication from here. Now you can see student ID is the primary key. Okay. But while converting this thing in a first normal form by this way, student ID alone is not the primary key because student ID is getting repeated. A student is learning multiple courses in a coaching institute. That's why student ID 12 is not the primary key. It's getting repeated over here as well. 13 is getting repeated over here as well. So Over here, we should be having a concept of composite key. Yesterday we didn't learn it. So we can say that a combination of student ID and course ID is unique in nature in this table. Please check and let me know if it's not possible or feasible. Because student ID 11 and course ID A11, the combination of these two column is unique over here in this table. Let's see and verify. This thing is not repeated. Just like for 12, 12 is getting repeated over here in student ID. But if we just taking into consideration of course IDs as well, just like 12 and A12, it's not repetitive. Similarly, 13 A11, 13 A14. So this is the concept of composite key. And this composite key is playing the role of primary key over here in this table. So during having the first normal form, we need to identify the primary keys of the table. Okay, which is the combination of student ID and course ID. And now we need to identify if there is any partial dependency of the entire primary key. Means apart from the primary keys, if there is any such columns available in the table which are having partial dependency on the primary key, there should be fully dependent column, there should be partial dependent column. Just like course fee. Course fee is, it's not totally dependent on the primary key over here. If we have partial dependency, we can create a new table just like this. For this example, I have splitted course fees from this table. I'm just making a second normal form table. While converting this table to the second normal form, I splitted this course fee not in here. I just splitted it to another table. Over there, only course ID versus course fee relationship is been set up. Course fee is directly related with course ID. There is no relationship or no direct relationship or no direct dependency of course fee with the student ID. Okay, course fee is totally dependent on each of the course ID. Suppose A11 means history. To learn history, the monthly course fee is 500. Okay, so each of them you can see it's a direct relationship. So while splitting this thing, I can split this thing up. I just put it over here. But you can see there should be repetitive because for each of the students we have repeated this. That is why it's repetitive, just like A11, A11, A11 500, A11 500. So we need to quickly eliminate this thing as well. I have eliminated and place it over here. Okay. So this is simply course ID and course fees mapping. And I have put this thing in another table. Over here, we just maintaining a student ID, student name, and which particular course ID is being assigned with that particular student. So now I can say the combination of these two tables are in second normal form. Okay, so whenever it's required, a particular student is paying how much. That is how the relationship is been established over here. There are course ID is a common column. Whenever I requires how much a particular students are paying, then we just need to have a join between these two column and retrieve the course fees information. What is join and how to join? We'll be quickly learning this thing in the next chapters when we'll be learning SQL. But as of now, we just try to relate the thing. Suppose student ID Sonu, how much he or she will be paying. So we just need to check Sonu is tagged with two different course IDs over here, A1 to A13. Now we need to move to this table. A1 to A13 is here. It's 800 and 300. So total 1100 to be paid by Sonu for the monthly fees. But we are keeping this thing in separate. This way, if we just storing the data in this way, it should be second normal form. The query is much easier and the table space should be also much smaller. Over here, it's maybe you can say that there is only 4 columns. Why it's not efficient way for storing the data? But practical scenario, there should not be 4 columns only. There should be lots of columns you can see over there. And we are splitting these things for this reason only. Just like the same reason we have splitted the last day, we have shown some example over there. Just like order table, customer table, address table. We are splitting this thing. Because in a coaching center, there should be lots of students available. Not only this four students over here. There should be lots of student available, but course ID should be very minimum. Maybe in the coaching center, there are 7 or 8 subjects to be learned. So the second table should be very small. So we do not have course fees for all the rows. We should not have to put course fees in the main table or main student table. Okay, that is how which table is requiring, the exact primary key relationship or exact dependency on the primary key to check the same thing. We can split up the table accordingly, whatever we have done over here. Okay, the concept is clear for everyone, or is there any stuck point while converting the second normal form? Because this is very, very important. And this is one of the main thing we need to follow in relational database. We need to check the same thing to make it a normalized form. Any doubt from anyone so far? No doubt. Okay. I hope from everyone it's clear. If no, please tell me. Okay. I hope yes for everyone, as there is no such response. Yeah, I just prepare one more columns. Okay. Is this the same thing? Yeah, someone is telling something. Sorry. Okay. So I just prepare another example over here just to understand the second normal form. So over here, you can see a big table over here, just like order ID. The particular information is taking order ID, customer name, which customer has purchased this thing, customer contact, customer city, product name, product brand, billing cost. Okay, I found this thing. But while storing the information in the relational database management system, as I mentioned, we need to make it a second normal form. How we are storing it? We are storing in this manner, order ID. Instead of putting all customers information, we are just removing this customers information from here to a customer table. And we are just putting a unique identifier for each of the customer and putting this unique identifier just like customer ID. Suppose I'm just eliminating this part into a new part called customer table. And I'm giving some customer IDs for that table. And I'm also putting these customer IDs over here to set up relationship between order and customers. Which customer ordered which particular orders. Okay. Same for product. For product, it's biscuit, cold drinks, just like this. A biscuit with having Britannia brand. I'm giving this product ID just like 111. Similarly for product, cold drinks, Pepsi, I'm just giving another product ID. Suppose 210. So I'm just calling this thing over here only. Okay. And billing cost I'm putting over here because billing cost is direct relationship with order ID. That's how we are segregating this thing, splitting this thing up to make it a second normal form. This is another example I'm just putting in front of you. If we are storing this thing in this way, this should be much more efficient way. We can, limit lots of rows over here. And why we should, put unnecessary all the customer related information in order table. So that is one of the thing. Okay. This is how we should have to maintain in second normal form. This is a good example I just set it over here. Okay. I hope there is no doubt from your side. I'm just moving to the next slide. If there is any, please tell me. Okay. So keys in SQL. I already mentioned this thing in last day, but let me quickly repeat the same thing once more time. Keys in SQL, there are primary keys and foreign keys. Those are the main thing, as I mentioned, just like this one. For this example over here, you can see for customer table, customer ID is the primary key over here. Okay, because I'll be inserting the records over here for each of the customer, but for each of the customers, I'll be giving only one customer ID. But the same customer ID can be repeated over here. Maybe the customer came again tomorrow to purchase something. So customer ID can be repeated over here in order table. We can say customer ID is the primary key in the customer table and customer ID is a foreign key in order table. Similarly for product ID. Okay, a different customer or the same customer can purchase the same product ID again, maybe after 2 or 3 days. Okay, so product ID can be repeated in order table, but product ID should be always unique in product table. We are maintaining a separate dimension for product. What is dimension? I'll be coming in later chapters. No need to worry about it. But just like product is a dimension, and this is the unique identifier of this product 111, which is referring a biscuit company. 210 is a product ID which is referring a cold drinks company. And same thing we are just having reference over here. So product ID over here is a foreign key. Product ID over here is a primary key. Okay. In order table, we are having order ID. It is the primary key only. Okay. So this way we are setting relationship between foreign key and primary key. And this is the main fundamental things to have in a relational database management system. I hope this concept is clear. And today we just gone through what is composite key. When we can see a particular single column is not quite sufficient to define the uniqueness of that particular table, then we need to think about combination of multiple columns, which can make the particular row as a unique one. Then instead of checking one particular column as a primary key, we can tell the combination of these two columns or three columns or multiple columns can be the representation of the primary key. Okay, so we can then tell that this is our primary key. This composite key can be our primary key. Composite key can be created not only two columns, it can be a sets of columns, maybe 2, 3, 4. Till now, we are not getting the uniqueness of the record until we are receiving the uniqueness of the record. Yeah, that I want to say. Okay. Okay. As there is no such doubt, moving to the database topic. Now, this relational database tables and all we need to put into databases. We are explaining all the things in Excel. That is fine. As I mentioned, Excel is not a sufficient things to store for big tables and all. And for relational database, to store the relational database, we are having lots of database in our market. In market there are lots of database. Let me just show you. Just like MySQL, Oracle, Microsoft SQL Server, Teradata, Postgres, Sybase, DB2, Redshift, Snowflake. I mentioned few of them. There are lots of databases available in the market. So we'll be taking MySQL over here for our demonstration purpose to learn the SQL. We'll be installing MySQL because this is one of the open source free tool available, the website. I have the portal. Let me just give you the same thing to you. Yeah. Please install the same thing in your system. Okay. So I'm just pinging the same thing to you over here for everyone, and download this big one. Two installer there. This is specially for offline version. So download this one, which should be 288 MBs in size. Download it and install it. Okay. Uh, the installation is not very hectic. It's also very simple. Just try to install it just one time. I mean, when the installation is already completed or it's going to be completed, they will be asking for a password. That should be your database password. So each day or each time when you will be logging to the database, that should be your password. When you will be installing that installer, there should be one UI. To access this database, there is a UI called MySQL Workbench. Okay. So I'm opening that MySQL Workbench. This is our database instance. By default, root should be our username. This is localhost means my local system. I have installed it. Double click. So this password they will be asking for each day when you will be logging to the database. Okay. So please remember that password, whatever you are putting there during the installation part. Okay. And here it's my database over here. Or rather, you can say it's the UI of the database. It's MySQL Workbench. Okay. So this is how the installation should be done. Please try to install it. Tomorrow onwards, we will be having the hands-on session on top of SQL, that structured query language. This is how we need to go ahead with the SQL query. SQL query means that how we do the, trying to create some new tables, trying to insert some data into the tables. We're trying to remove some records. We're trying to do all kind of data manipulation on top of the tables. Okay. Okay. Now, what are the next topics to be covered? Database schemas. Okay. So as I have opened the particular databases, you can see in the left-hand panel, they're all called database schemas. There is nothing but different databases, instances. Okay. If you are just installing MySQL, you can see there are by default 3 or 4 databases should be present. Okay. I have created a new database schemas over here, just like Teradata underscore training, because for the training purpose, I'll be creating all my tables inside these databases. If I just click on this arrow, you can see from the previous session, I have created this many tables. Okay, I'll be dropping all those tables by today only, so that from tomorrow onwards, we'll be learning the new tables and all. We can create the new tables from here only. Okay. So it's not only tables. Tables is the basic unit of the database. We are learning everything on top of tables as of now. There are other components in the databases as well, just like views, store procedures, functions. Okay. We'll be gradually learning those things as well. But table is the basic unit, we need to learn everything on top of table. If we learn tables quite easily, the all operations related to tables and all, views and store procedures can be built on top of tables only. And it's very easy. If we know all the information related to table, we can quickly handle views and store procedures as well. Okay, now how to create a new database instance? We can put some commands over here, create database name, or from UI side, I can just select any one of the database and Right click on top of that. There is an option of create schema. Okay, if I just create a schema, suppose I'm creating a schema. Suppose I'm putting test, only test schema. So by default, back in the backend, as I mentioned, it will be running this query, create schema, a particular schema name, which is called test. But over here, I'm not putting this thing. I'm just doing this thing from UI side. In backend, they will be automatically throwing this thing. Just I need to click apply. I applied it, finish it, and you can see this is our new schema has been created. Okay. Similarly, I can put drop schema name that is called test. The schema will be dropped from here. This is the query window where we will be writing our codes. And in the output, we can get the output. Here is a log section as well. I can delete this thing by right click, drop schema, or I can put drop schema name. Excuse me. In the left hand panel of schema editor, you can see some administration portion. This is the admin part. So in database can be managed by database administrator. I'll be not mentioning much thing on top of administration part because we are learning data engineering part. So in practical purpose, if you are onboarded in a project, especially there should be a different DBA team or database administrator team who will be managing the database. Managing means they will be, managing the access part of different resources. They will be checking the databases, whether it's running fine or not, any issues with the database. Maybe the server is shut down. They'll be checking the issues and helping the teams to get rid of these issues. And so the admin portions, they will be checking it. As I have installed this thing into my local system, we are the admin itself of this database. We can check those things: server status, client connection, users and their privileges. But it's not required as of now because it's my machine. I am using it. If there is something that, the same PCs can be used by multiple persons over here, I can set up different users and their privileges. Different privileges I can also set. Suppose I can create read-only privileges for particular users. They cannot run any such queries which will be updating my database or which will be eliminating or deleting something. Someone is just deleting some rows in a table, which is not possible if I'm not giving them that particular privileges. So I can control, or admin can control this kind of thing over here. But as of now, we are not much focusing on the administration part because that should be controlled by a different team when we are live in a project. I'll be just focusing on the database, especially on development purpose, how we can create new tables, how we can manipulate those tables, how we can aggregate the data and all. Okay. Okay. One more thing, important thing I just want to mention. As I mentioned, there are various databases available over here. We are learning MySQL. So what happened if we are live in a project with a different database? What will happen? Just I want to mention that if we are learning any one of the database, the basic syntax is based on SQL, which is similar, almost 90 or 95% similar for all the databases. Okay, no need to worry about that particular point. Okay, we can learn any of the databases. The SQL syntax are almost same, but there are few differences for each of the databases. They are having their own function, inbuilt functions are there. So just we need to, think about that part only. Suppose we learn MySQL, there are some inbuilt functions to handle some operations. That inbuilt function syntax can be different in Oracle. Okay. So, but if you have quite experience in a particular database, you can also handle it quickly. Just search with the basic function in web. They can help you for that particular database, which is the suitable syntax. But the basic things you must have to learn so that you are quite confident as well what to search in web. Okay. So over here, we'll be just checking the basic syntaxes of MySQL and how to handle all kind of databases, queries and all. From the basic level, we'll be learning from tomorrow onwards. I hope you can install MySQL database at your local system. And if there is any stuck point or anything, we can definitely check it in tomorrow's session. But try to install the same thing so that we can go ahead parallelly when we'll be typing the codes over here, SQL queries over here. You can run the same thing at your system. Okay. So
Sure, I'll do that.
yeah.
Sure.
Yeah. Okay. Thanks. There is nothing. Yeah, I have mentioned this thing, database objects. Yeah, I'll be coming to this point. As of now, we'll be focusing on tables that I mentioned. Maybe when we'll be learning all the things, tables, we'll be learning these things one by one. And yeah, as of now, nothing. Those are the things for today's session. Let's connect tomorrow. I hope SQL will be up for you and we'll be doing queries over here directly. We'll be learning queries, the code part, and we can have a quick hands-on, and that should be much more interesting as well. Okay. Okay. Any doubts so far from anyone? Because we are almost end of the session for today.
So, as we are recording these sessions, where can we get these sessions recording?
Yeah, I'll be just putting the recording. I'm just recording this thing into my system only. Okay. When the recording will be completed, I'll be giving the recording to one of the Teradata admin team member. Okay. And I'll be requesting him to he will be pushing this recording, maybe some YouTube link of Teradata. And I'll
Oh,
be requesting for the first day, today, he will be putting the recording link into the WhatsApp group so that you can daily basis check the recording. Okay.
sure.
Sometimes there is a syncing issue. Suppose I provided them and they have missed it, or some days I maybe forgot to provide the link. Then you can wait for 1 or 2 days. If they are not uploading this kind of thing, then you can tell me. I can directly give you my OneDrive link so that you can directly download it from my OneDrive. Okay.
Okay, so we can get today's and yesterday's recording sometime later by the Tetra team, right?
Correct. I forgot to, yeah, frankly speaking, I forgot to give the recording of yesterday's session. So as soon as today's recording is completed, as I close the session, maybe after 15 or 20 minutes, the recording will be ready. So I'll be handing over both of the recordings to the admin team. And they will be, as soon as they will be completing, pushing this recording to the YouTube link, then they will be giving you the link. Okay. But I'll be definitely after 20 minutes from now, after closing this session, I'll be giving, yesterday's recording as well as today's recording to him. Okay. Okay, then, as there is no
Thanks.
such doubt, let's connect tomorrow with, having some more insights on top of SQL. Thank you, everyone. Bye bye.
Thank you. Bye.
Thank you.